Welcome to LNP Renewable System Integrator. Today we are going to discuss some of the basics of IoTs, that is Internet of Things. So we had classified this session into 6 parts. So we had already discussed about the part 1 and 2. If you missed out those videos, we are providing the link below, so that by referring that link you might be pretty clear about the things that we have discussed in the part 1 and 2. Come, let's get into the part 3. So what are the things that we are going to discuss in the part 3? Here in part 3 we are going to discuss and what are the important protocols, that is access technologies, which is being used for IEEE 802.11ah, okay, where it is commonly used, and what is the physical layer format, MAC layer and topologies for this IEEE 802.11ah protocol, and what are the benefits of using this IEEE 802.11ah protocol, sectorization, okay, and what is LoRaWAN and what are the layers of LoRaWAN, and what is the relationship between the speed and the bandwidth for the LoRaWAN, okay, and what is the MAC layer and the topology used for LoRaWAN protocols, and how the LoRaWAN architecture looks like, okay, and what is the LoRaWAN security looks like, and we are making a comparison between the competitive technologies with the LoRaWAN, okay. And if we get into the IEEE 802.11ah, okay, it is nothing but a advancement of IEEE 802.11 Wi-Fi, okay. Why we want to make an advancement over the Wi-Fi? Because nowadays we are having so many sensors, meters in the smart grids, okay. So in order to establish the communication with these sensors and the meters that we are using the smart grid, we need some protocol which has an advancement over this Wi-Fi, that is the one IEEE 802.11ah. With the help of this we can able to monitor, okay, and we can do the process with the help of the sensors. We can do the indoor healthcare systems, okay, and even we can go for this home and the building automation sensors also with the help of this IEEE 802.11ah protocols. And it is an extended range over the Wi-Fi network. And if you're getting into the MAC layer, okay, it includes how many number of devices and what is the MAC header, okay, and null data packet support, grouping and sectorization, okay, RA, that is restricted access window, and target wait time, okay. All these things comes into this MAC layer of the IEEE 802.11ah, okay. And if you're going for a number of devices up to 8192 per access point we can use, okay. So access header is for, we are using it mainly for the efficient communication, okay. And if you're going for this null data point support, okay, it controls the management frames. And why we are going for grouping and sectorization? It enables the application to use the antennas and also even group stations, okay. Why we are going for because it controls algorithm that avoid the simultaneous transmission when many devices are present and provide the fair access to the wireless network, okay. Target wake up time. It reduces the energy consumption by permitting an access point to define time when a device can access the network. Next is the speed frame exchange. It enables the application, the endpoint, to exchange the frames during a reserved transmit opportunity. Most important factor of this MAC layer is that it mainly focuses on power consumption and mechanism to allow the low power Wi-Fi station to wake up less often and operate more efficiently. So it deploys the star topology. So as you can see, okay, with the help of the star topology we can have a sectorized beam, okay, we can reduce the interface from the adjacent DSS via the sectorized beam reception, okay. LoRaWAN. So in the recent days a new wireless technology came into existence, that is LoRaWAN. That is nothing but the expansion of this LoRaWAN is low power wide area network, okay. So nowadays particularly we are adapted to battery powered endpoints. So in such places energy power consumption should be less. So for that we are going for this LoRaWAN. And if you get into the layers of this LoRaWAN, we have a LoRa alliances based on the different hertz, and we have a modulation, physical modulation layer, and we have a LoRaWAN MAC, okay. Over it we are having a IPv6, RA, MQTT and CO. And if you get into the configuration of LoRa based on the frequency hertz, we have different configurations. So as you can see in the table, okay, we can have a relation. If you try to correlate the relationship between the SF and the data rate, okay, the channel bandwidth value are also evident in it, very much pretty. The SF is getting reduced, to a value of 7, and the data increases to 5470 bytes. Okay, and if you get into the MAC layer of this LoRaWAN, okay, it has MAC header, MAC payload, and MC, that is message MIC, that is message integrity code. Okay, so these devices we can classify it into 3 classes: class A, class B, and class C. So class A is nothing but the default implementation, optimized for battery powered nodes, and class B, which is specifically designed for experimental, okay, and class C, which is particularly ordered for powered nodes. Okay, next the topology which is often used by this LoRaWAN is start to start topology. So as you can see, like a cable, we have a central layer, over it we have an insulation, over it we have another insulation. In the same method, if you can look into the LoRaWAN architecture, we have a LoRaWAN radio physical layer, we have a IP tunnel, we have a IP transport, in between we are having a app data, okay, and we have a LoRaWAN MAC gateways, and we have a network services and application layer. And if you get depth into the LoRaWAN security system, okay, these devices encrypt the data end to end, okay, it separates the network encrypt to the NS, okay, and these devices sends the packet of informations, okay, all the APs into the range receives the packets, okay, so it is decrypt using the app key. Next most important thing that we are using in this LoRaWAN is that ABP, that is activation by personalization, and even for OTAA, that is over the air activation. Okay, these endpoints ABP does not need to run a joint procedure as their individual details, including the DVADR and NWKS key and apps key session keys. These endpoints are allowed to dynamically join a particular LoRaWAN network after successfully going through a joint procedure. And if you get into the characteristic, okay, if you are making a comparison of a LoRaWAN with the latest technologies, if you are going for a frequency band, okay, this LoRaWAN and Sigfox has at most same number of frequency ranges, and if you are going for a modulation, this LoRaWAN is using chirp spectrum, spread spectrum technology, and Sigfox is using the ultra narrowband, whereas this Ingenu is using DSS. And if you are going for a topology, Sigfox is star, whereas LoRaWAN is star to star topology. And if you are going for a data rates, the data rate is more in the LoRaWAN. Okay, and if you are going for adaptive data rate, LoRaWAN is good at it. Even for the payload and two-way communication, LoRaWAN is better. And even for the geolocation and roamings, this LoRaWAN is applicable. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We had provided the contact details here. Okay, the section is not yet over. We have so many parts to discuss. So if you missed out any of the parts, we are providing the links below the session, because this session consists of 6 parts. Okay, if you missed out any of the sessions, so we are providing the link here below in the description, so that by navigating through the different parts, you can try to know about the basics of this IoTs. Thank you so much. We are also providing design, installation, testing and commissioning, consulting supports for building automation, the home automation. And if you are a college student, if you want to work in abroad like GCC countries, and if you want to have enough knowledge about the PLC programming, and you want to know about the building management and the automation system, if you want to know about the Internet of Things application in the PLCs, you can contact us. We have provided the contact details here. Thank you so much.